So here's one way that I would go about doing the task that I've set out for you in section 3 of the resolution worksheet. So the assignment is find the counterparts between IRAC and Ys, with bonus points if you get the names of the coordinates, and the list of sources is given here, and I've given you a link to a regions file here if it will make it easier. So if you click on that link, it takes you to this parameter file, but what you actually want is the regions file. There's the regions file itself. Note that in order to convince the wiki that it's a text file, I had to add the txt extension. To convince DS9 that it's a regions file, you'll have to save this to disk and then put it back as a, get rid of the .txt and keep it as a regions file. So what I'm going to do is go back to the instructions here, and it says you get the list of sources here, and they're in the regions file. So let's go over here, and I have then a bunch of files. I'm going to load in the glimpse files and the Ys files. For simplicity, I am going to do just 1 and 2, and not the rest of the files that I have in here. So these are big files. It's going to take a little while for DS9 to load them. It is possible that your machine does not have enough memory to do that elegantly, in which case you're kind of stuck, and you'll have to either find a different computer or you do this using Finder Chart. So here I have loaded, there's the glimpse IRAC 1, glimpse IRAC 2, Ys 1, and Ys 2. So I'm going to do, I have this set up to do a default stretch. Yours may come up with a different stretch, in which case then you go and change the stretch, whatever you want. I've got 4 images loaded. Let's go to frame single. Let's do region, load. Come on, talk to me. Okay, and I want it to go and get the section 3 sources regions file, and I want to load it into all of the frames, not just the current one. Okay, so the next thing I need to do is find where those regions went. So let's zoom to fit. Okay, it's enormous, and I actually can't even see the regions file. I suspect, though, that it's in here. So let's zoom in. Yep, there are some of the regions. So the green ones are the easy, the yellow ones are the hard, and the red one is the really hard. So let's go over here. So I've got the sources there. Let's change the stretch so that we can actually see what's going on in this image. So let's change the top to 2. That's a lot better. Frame next. Okay, let me go back to the previous one. Okay, so I know that the stuff is right there. So what I want to do, it's in the field of view that I'm looking at. So I'm going to do frame, match, frame, WCS. Okay, so now it's put north up, and it's given me the locations of those, and there's some more over there. Okay, so I'll put it in the middle, do frame, match, frame, WCS again, and now when I go to the next frame, see the regions file, the regions aren't moving. That's because all the images are lined up in the DS9. So let's go here and let's change that stretch. That's much better. Next, let's change that stretch. Let's see, and go a little bit higher. Okay, and then next, let's go a little bit higher still. Okay, so if I go then to the next one. Okay, so let's try these 2 guys. Because I think those are the first 2 on the list. Let's check. Let's go back over here. The first one is 5, 28, 17, 12. So let's go and put our mouse on top of this. 5, 28, 17.2 is darn close. 34, 28, 03. So what I'm doing is I'm looking at the coordinates there as I'm on top of it. Okay, and then the other one is 5, 28, 16, 34, 27, 28. Yep, so those 2 are the first 2. Okay, so this is an IRAC image. I can tell because the PSF is triangular. So let's, I've centered that. I'm going to do frame, match, frame, WCS, and then frame, tile. So there's IRAC 1, IRAC 2, WISE 1, WISE 2, with the same two sources circled in each one. So let's look at this really carefully and critically. So you can see there's a big resolution difference. But one source there is pretty much one source there, one source, one source, one source, one source, one source, one source. So good, I think we found the counterparts between WISE and IRAC. But let's look more details with an eye towards what's going to happen in a few minutes. This circle is not exactly centered on that source. Neither is this one, but by a lesser degree. This circle is also not centered on this source in the same direction. This circle is also offset. So I suspect what's going on is that the coordinates given by Jose et al. For this H alpha star are not quite the same coordinates as what is in 2MASS and WISE. 2MASS and WISE are fundamentally the same coordinate system, so they should be linked really closely, like to sub-tenths of an arcsecond. So in this case, it's pretty unambiguous, I think, that the source that Jose et al. Meant is this one, and that the source that Jose et al. Meant here is that one. And so it's probably a good match. In a few minutes, though, it's probably going to be harder to make that assertion. And we're going to have to make judgment calls because the uncertainties in the position of the catalogs from Jose et al. Are larger than the positional uncertainties between 2MASS and WISE. So then that's the point at which we need to make some informed judgment calls. Now, in doing this, you can certainly find the counterparts, and you can certainly see that the resolution is a lot different. And you can see things like, well, there's two sources there that are or three sources actually there that aren't resolved in WISE. And there's two sources here that aren't resolved in WISE, but they may be anonymous background sources that we don't care too much about. For the sources that we've identified so far that we care about, there do seem to be just the single sources. But my bonus question to you here, well, first of all, was the distance between them, but then also was to find the coordinate-based names from WISE and 2MASS and Glimpse. So we can go and see if I have the 2MASS image here. Frame, new, file, open. Let's go find the 2MASS image. Okay, it's going to load it in shortly, eventually, maybe. I don't know where it went. Frame, single. It's still thinking about it, maybe. That's weird. File, open. Give me the K-band image. Weird. Okay, let's do frame, next, so we know those are there. Frame, match, frame, WCS, and then next. That's the K-band image. No, it's not. Next, next, next. That's the K-band image. Very strange. I don't know where the K-band image went. Well, if you load it in, it should have snapped it to the same position. All right, but let's go and see if we can get the catalog numbers. And in order to do that, you need to find your chart. So I went and copied that first source position. I'm going to put it in here. And it seems like it was okay with the comma, but I'll take that out. We want an image size. Yeah, that's fine. You know, could be smaller. Could be, let's see, let's do an arc minute rather than 5 arc minutes. There's no Sloan data. Do DSS, 2MASS, and WISE. And yes, I do want to search the corresponding catalog. 5 arc seconds is maybe a little small. It's okay if you have really good positions. It's probably going to be okay for this, but it may not be okay for some of the other sources in our list. Search. So it's going to go and get little images of the sources, and look, the position is offset in the same direction and about the same amplitude as what we already figured out was the positional offsets between the source from Jose et al. And the 2MASS and WISE. It's also offset for DSS. There's the source for 2mass and the source for y's. So if you look closely on the DSS, you've only got the blue circle. The blue circle is our search target. If you go down a little bit further, you can see there's some other overlays on the 2mass image. If we go to the 2mass catalog, it has overlaid that source on that position. If we go back and ask it to search over a larger radius, let's see if it will catch more sources. Yep, so it's overlaid the catalog on top. So that source is right on top of the source we see in the image. That source is right on top of the source we see in the image. I don't know what's going on here. I don't know why that source isn't there. That source is right on top of the source we care about. So as you may have noticed, as I'm clicking around in the image, the source that's highlighted in the catalog changes, and it works the other way too. So the source that we want is the one here, because we're pretty sure that's the one corresponding to the source we care about. Scroll over here. That's the coordinate-based position, where the coordinate-based name of the counterpart from 2mass for this source. So that's the answer to the bonus question. There's its J, J, H, and K measures in magnitude of this source. Let's go down to Y's, and it's got the same thing. Y's finds that source, and this source, and then that source. That's the bright source. That's the source we care about. That's the counterpart. That's him. And if you scroll over, there's the measurement in Y's 1, Y's 2, Y's 3, and Y's 4. So that's the counterpart. Now, how do we find the glimpse counterpart? Well, go up to the Catalogs tab. Just as in the other interfaces, you can search all of Spitzer's holdings. So let's do a cone search. That is 2 arc minutes. We want Spitzer. We want glimpse. And we want the glimpse 3D. No, we want glimpse. What did we want? Glimpse 360. More complete, less reliable. Meaning that, so there's 2 catalogs from Glimpse 360. One gives you absolutely everything that might possibly be a source, but it probably also contains some junk, which is that. Glimpse 360 catalog means everything that's in there is guaranteed to be a source, but not every source may be in the catalog. For our purposes, let's do the archive. Search. Now, if you search over a huge region, it's going to take a long time to bring back the catalog. In this case, there's only 240 sources in this region, so it didn't take too long at all. Now, if we want to, now how do we know which source is the one we care about? We want to overlay this catalog on one of these images. Let's pick the K-band image. Let's go up to the layers icon. It's showing 2mass on this image. It could, if we wanted, show the Y's catalog on top, but we don't need that. We want the Spitzer catalog overlaid. Look how many more sources it finds. Let's make that catalog a different color than the 2mass catalog, just so that it's easier to tell what's going on. There's the glimpse catalog. So turn it off and on. It finds those same 4 sources that 2mass does, plus many more, including this one and some other ones you can barely see in the K-band image. But now we know what we want. We want that Spitzer glimpse source. Click on it. There, Spitzer glimpse. Let's check and make sure that it's the same as the 2mass source. 706 is the end of the RA. 706 is the end of the RA. So that's our guy right there. We scroll over and we can find, that's the JH and K they copied over from 2mass. There's the 3.6 and 4.5 magnitudes that they obtained from their data. So that's how I would go about finding the counterparts in the catalog, is I would use Finder Chart, because Finder Chart gives you really transparent, easy, interactive access to the catalogs. You could, of course, also go and download the catalogs and go and look through the file yourself and find the match. But I find it difficult to do spherical trigonometry in my head. I find it a lot easier to let the machine overlay it and then click on the source to identify the counterpart that you care about. I would do the same thing for the other sources in either DS9 or Finder Chart, or maybe both, depending on exactly what I'm seeing in the images and depending on exactly how confusing the results are. There are different strengths and weaknesses of these two tools, and different abilities that you have, slightly different abilities that you have in the two tools that enable you to manipulate the images and the data in slightly different ways. Now, for the rest of the resolution worksheet, there are a total of 7 sources to investigate. But in the context of the next steps of what we're going to do, we need to do this same exercise for all of the H-alpha sources from Jose et al. And all the OB stars from Jose et al. Because once you get through all of this, especially this last one, you'll see there's a kind of a large range of coordinate uncertainties. And so we're going to need to go through by hand and identify what the counterparts are in these catalogs, because the computer's not capable of doing it by itself. So the way that I would do that is I would go back to Finder Chart and do the multiple positions option. And I will mail you the Jose et al. Tables. The table 4 was the H-alpha stars, and the table 6 was the OB stars. So I can give it to you in IPAC table format. There's the original plain text format, and there's the regions file. For searching, we want the table file. I'm going to open. Image size, 1 arc minute is probably fine. Search radius, that's probably fine. Search. So it will go and give you, okay, so this catalog has 25 sources in it. And this is the list of input, right ascension, and declination. Now, the bash search for Finder Chart is occasionally buggy in ways that I don't entirely understand. There's some bugs I do understand that are on the list to fix, and there's some bugs I don't entirely understand. Why the 2-mass search succeeded and the WISE catalog failed, I don't know. If we just do it again, it might succeed. Nope. Okay. So it's Wednesday morning, which means that sometimes they're doing maintenance on the databases. So that may be exactly why that failed. You may just have to try it times other than Wednesday morning. So there's the 2-mass searches that it found. So note that so row 1 has 1 line in the 2-mass. Row 2 has 3 lines in what it found. So for each one of these sources, row 1, the blue circle is our target. There does seem to be really close to a target there, really close to a target there, and have a clean, well-detected WISE source there. So then what you would do is either write down or copy and paste or something, a note of this source number 1 in, let's actually do that. Let's go over to the Jose et al. Let's drop the catalog table into my text editor. Now, I don't want to, actually, let's not muck it up. Let's copy and paste the file. Let's do table 1 notes.text. Okay. Yes, add. No, I want table notes.text. Yeah. Okay. So now I have each one of the input sources. Okay, so object source number 1, I can put here single source, nice, and then 2-mass match is, I come over here, find the 2-mass match here. Oh, let's make sure it's the right match. Yep, it's that one. So copy that and go back to my text editor and paste it in there. Now, the nice thing about 2-mass and WISE being so close together is that once you've identified the counterpart in one, it becomes trivially easy for the computer to find the match in the other because the positions are so well matched. So in other words, what this note is saying is that this right ascension and declination, this source corresponds to this counterpart in 2-mass at this position. Yeah, I know it's in different units. If you convert this to decimal degrees, you'll see it's slightly different. As long as we have one match, then we can find the counterpart to it in all the other catalogs. So you don't have to go through and copy 2-mass and WISE and all the photometry. If you just copy one, that's good enough, and then we can do the matches from there. Source number 2 on the list. Now, it found several sources there. Look, there's an arc of emission in DSS. Okay, we may have to muck about with the stretch to see if we believe that source. That bright source there is pulling the stretch off. There is a source there. I believe that. If you can look up in the upper right here, see there's definitely a point source underneath that. You could also turn off the overlays if you wanted to make sure there was a source there. So there's definitely a source there, and I believe that, and I believe that counterpart. For Y's, I believe that that's the match in 1 and 2. There probably isn't really a source there in 3 and 4. So you can come over here and say single source arc of neb at pos clear to mass match, and then copy in the source name. But let's see, and y is 1, y is 2, but not y is 3, y is 4. So that's the kind of thing we need to do for each one of the table 4 objects and the table 6 objects, and eventually the objects from Xavier too, but these are the ones that are going to have more positional uncertainties and more judgment calls. I don't care how you take the notes, plain text, Excel, whatever you want. Post-it, probably not so good. But as long as you are taking the notes in a way that makes sense to you and that you can explain to me what it is that you have, then we can compare results. And if we all agree that the source that you found the counterpart, then there's no issue. We can just go on. But if we disagree about what the counterparts are, then we need to talk about it on the phone. So that's the idea. Go through table 4, table 6, find the counterparts, and let's compare notes.